Assalamualaikum warahmatullahi wabarakatuh. Today we will present about our project implementation and UART Uart link on FPGA board using VERILOG. So this is our group member.
My name is Dora Lasmira Afrika binti Lawasa. My matrix number is DE160029.
My name is Nurul Idani binti Sulaiman and my matric number is AE170014.
My name is Nurul Fahana binti Santosa. My matric number AE170043.
Hi, Assalamualaikum. My name is Nurul Zainani binti Zaini. Matric number is AE170037.
Abstract. This project is about implementation of UART link on FPGA board by using VERILOG. This project is fully conducted by using Quartus 2 software version 13. This development is to send some data to another FPGA development board which also have a UART is conducted in bidirectional asynchronous communication between two FPGA boards. The data field can be varied from 4 bits to 8 bits. Introduction. UART controller is an integrated feature in microcontroller that allows data to be transmitted without sender send clock signal and received by the receiver. In order for the data to be transmitted, both transmit and receiver must have an identical baud rate. The purpose of this project is to check the input or output of UART link on FPGA board using VERILOG. FPGA board is a device that manufactured by Altera Corporation. This device provides an ideal vehicle for an advanced design prototyping in multimedia storage and networking. Coding in Altera Quartus will be encode of the input or output and transmit the data into FPGA board. The Altera Quartus 2 design software provides a complete multi-platform design environment that easily adapts with a specific design needed.
The objective of this project is to design a simple application of universal asynchronous receiver or transmitter UART on FPGA board using VERILOG. The second one is to apply the knowledge of UART on the project. And the third one is to understand how UART transmitted and received the encoded data by using VERILOG. Next one is scope or limitation of the project. For this project, it focuses on the asynchronous receiver or transmitter UART and FPGA board using VERILOG code. And 8 bits data will be transmitted into FPGA DE2 board using VERILOG codes and simulate on Quartus software. However, for this project, we focus on the simulation only. And this project will use Quartus 2 version 13 software in order to get the timing diagram and RTL view.
For methodology, the modeling design consideration also included in this chapter, which is contain the simulation concept of the modeling. This part will describe about the definition, classification, and specification of the software used, which is Quartus 2 version 13, elaboration of UART data frame, transmitter, receiver, and baud rate generator will be included. Hence, the development of flowchart and diagram will be illustrated to have clear and better explanation. This is the flowchart of our project, and this is the block diagram. For project description, we have 4 points. First one is UART data frame. As you can see, this is the data frame diagram for our project, where several data field that is being considered, which is start bit, data bit, and stop bits. For baud rate generator, we are using Baltic Gen. The only input in the internal 100 MHz clock signal, and the output is the required Baltic signal. For UART transmitter, there are 3 input to the transmitter, which are parallel add set of input which contain the input data. The starting input acts as a transmission on or off switch. Parallel data coming from add line are time synchronously added together in the rhythm of the Baltic, which give the out as a serial data stream on a single line. For Uart receiver, Uart is taking two input, which are input clock signal and serial data input. Input signal data is again formed into a set of 8 data lines after each packet is arrived into the receiver.
Hi, I'm Zainani. I will present about the timing diagram analysis result and simulation. Figure 3 shows the timing diagram and Figure 4 shows the RTL design diagram. Hi, Assalamualaikum. My name is Nur Zainani binti Zaini. Metric number AE170037, and I will present about the simulation of our project. Okay, the coding for the UART on FPGA board is like this. We name it as test 4. Okay, we get this coding from the internet, and then we elaborate it. Okay, first the input that we have is clock, transmitter device, and transmitter byte. We use 8 bits. Okay, for the output, transmitter active, transmitter serial, and transmitter done. Transmitter done is for the configuration only. Okay, we state the parameter here. For idle, start bit, data bit, stop bit, and cleanup. Okay, and then we register the bits here. Okay, for the idle case, we begin with this. Transmitter serial, we drive line hide for idle. Idle is to deactivate the process. Okay, and then we start with start bit. Start bit, the coding for start bit is here. So when wait clocks per bit 1 clock cycle for start bit finish, we make the coding like this. Okay, for the data bits, the coding is like this. Okay, the data bits, if we want to check if we had sent out all the bits, we have to code like this. If R bit index is less than 7, then we begin R bit index, and so on. Okay, for the stop bit equal to 1, we want to send out the stop bit. Okay, then we begin transmitter serial 1 bit, and then we wait clock per bit 1 clock cycle for stop bit to finish to get the output. Okay, then we assign the transmitter active and transmitter done here, and module. Then we run the coding. This will take a few times. Okay, the coding was successful. Okay, now we will continue about the RTL diagram. Okay, so we get our RTL diagram is like this actually. Like this, it is a little bit complex because we didn't manage to simplify it here. Okay, as we have this all elements. Okay, I will zoom it a little bit. Here is our logic gates, our block diagram. Okay, here is our input, transmitter byte, clock, and then Here is our output serial. Here is our output transmitter serial. Okay. Okay, after we have simulated the RTL diagram, I will show you about the timing diagram that we get from this. Okay. So we had already get the timing diagram from here. Okay, here is we run functional simulation. Okay, hence we get our result is here just for the serial only, because the transmitter active and transmitter done is for the configuration only, and then this is our result. Higher, higher, higher. When it has 000, it's only lower at point here only. Okay. That is for the simulation. Thank you.
As a conclusion, we are able to develop a simple application of UART and FPGA board using VERILOG, and we managed to implement an UART link on FPGA board using VERILOG. The output we show on the timing diagram and RTL view in the Quartus 2 software, and at the end of this project, we are able to understand more on UART and FPGA concept where it has provided many features.
Q&A. First, what are the unique features of your CHAO project? For this project, the unique features will support to implementing a UART link for a FPGA development, but using VERILOG as HDL and send SAM data.
What did you learn from doing this project? So after completing this project, what I have learned is I get to enhance my coding skill. I also get to be more familiar with UART concept and understand more on how to implement it into CHAO subject.
What are the challenges from doing this project? The challenges things in this project is the coding part and timing diagram. For the timing diagram, it is hard for us to come up with an output. The output for the timing diagram did not come out well due to some error in the coding. As for the coding, we are lack of skills in coding, thus it is hard for us to correct some errors in the coding. And the third one is it is hard to communicate with group members due to online classes. We use an online platform to communicate with each other, so it might lead to a miscommunication with the group members.
Okay, my answers for the question of give one sentence to summarize our project is, in conclusions, we are able to know the advantage and disadvantage of using the universal asynchronous receiver and transmitter and FPGA board. As the FPGA board has higher speed, lower power consumption, smaller size, and lower cost, while UART is the protocol that permit short distance, lower cost, and exchange data between the processor and the peripherals.